then only all the things are possible. Not, it will not come normally, it will come, but here when striking, it strike normally. Then only can retrace path. And there's a basic necessity condition. It will happen practically. We may doubt it, sir. Is it possible? Yes, it is possible. Okay, this we know value of theta. This will take theta. We'll take this is theta. Then this will be theta. X component of velocity, Y component of velocity we can define. So during collision, it will have Vx. This will be Vy. So tan theta, I think theta value we know it, R by 2 by R. Sin theta. Theta equal to 30 degrees. So therefore tan theta equal to Vy by Vx. This is a relationship between the components. Now what is Vy? How much of height it will descend? H equal to 4R is given. What is this total height? The total height is 4R. That will indicate. I think some little bit some geometry is there. We can manage this. So it will strike at a distance R by 2. So this is R by 2. Then how much of height it will descend? 7R by 2. So Y should be equal to so what is Vy? Vy we can write it as 2GY. So 2G into 7R by 2. So 7GR. Horizontal component of velocity has to remain same, U only. Find U is asking. So tan theta, I'll substitute. So 1 by root 3. Vy is equal to root 7GR. This is U. Mathematics very simple all, but it should, if it strikes normally, then only it can retrace path. What is the basic necessity condition? The ball must strike the hemisphere normally at point P. At point P, we'll write like this. So that it can trace the, it can retrace so that it can retrace the path. And moreover, elastic collision equal to 1.